Lucky to have Dr. John Guslander here to give a talk. John is a GJH board member for many years. He also is the person running all of our field trips. So if you have field trip ideas, John is the person to talk to. He's done Tuesday talk, and we've lost track of how many lunch talks, 3 or 4. John has a Bachelor of Science in Chemistry degree from the University of Montana and a PhD from University of Oregon in physical chemistry, which, having taken physical chemistry, I can assure you is really, really hard. So please join me in welcoming John.
No, I can do it. So this talk originated from a class I gave up at Tardy to some of the tour guides up there who all had college degrees in things like environmental science, ecology, that kind of stuff. And they wanted to know how to find out about the local geology because they would get asked questions when they were guiding people around Tardy. And so I went up there to teach them how to get some information about the local area. So a lot of this slideshow is how you can get information about where you're visiting, like geologic maps, most useful thing. And then the other thing at the end is how to try to make sense of minerals and rocks using chemistry, because it's a very intimidating subject, I find anyway, to just look at a rock and just what's in it, and what are people talking about, you know? And so, it's not loud enough? So that's what the second part is. And then I brought a bunch of samples. There's 30 slides in the show, and so there should be plenty of time to look at the rocks afterwards. Okay, so the first part, we're going to go to Ashton, Idaho. I'm not an expert on this area, but it's a good way to see how to find out information. And I've got some good rocks. Next, we'll go to Copper Mountain, which I've been to a couple of times, and do the same thing. And then we'll look at silicate minerals and rocks. So this is us right here, Jackson. Go over the pass to Victor and Driggs, which I'm assuming most of you have done, and go like you're going to Idaho Falls, and then you go north to Ashton like you're going to Bozeman, let's say, or West Yellowstone. And when you get right here, if you look to the north, you're going to see a kind of, not really a cliff, but a fairly quick rise. So this is Google Earth's view. So you see this big feature here, right, that you drive up. It's kind of busy traffic here, so most of the time, at least most of the first times I went through here, I ignored it all. And just, you know, there's lots of trucks and things. But you go up a fairly steep incline right here, right? And then you get up on a flat spot, a plateau. And you drive on that plateau for a long ways. This is Ashton again. I'll get to where I got this information in a couple slides, but so if you start out at Ashton and you're climbing up that highway, right at the base by the Warm River is Huckleberry Tuff, all kinds of it. And then as you go up a little ways further, there's a boundary here where there's an ashfall layer, and then it's Mesa Falls Tuff, and then you're on top. So the first and second Yellowstone caldera eruptions are right there. Then this is called Island Park, this whole area. And you go a little ways, like, I don't know, 10, 20 miles, and you'll get to a place called Max Inn. It's a gas station, and just before it, there's a paved road to the east. If you take that, you can get right to this edge of the Lava Creek Tuff. There's a little, like, pond that people go there with their kids. So there's a development there, and you can go and walk around on this. And all of this is national forest. You can pick up rocks, you can drive around. In fact, there's so many roads up here, you could get lost. And there's a lot of wet spots, because it's just like Yellowstone, only it's not hot. So there's lots and lots of water features, but they're not making geysers and steam. So it's like Yellowstone that's cooled off. So you can, one thing you can see right away is most of the water features in Yellowstone must be from rainfall and snowmelt. Because you get all that here, it's just not evaporating in steam. So fishermen like going up here, there's big, slow-moving streams. I don't know much about fishing.
And so the Lava Creek is the 640,000
Yes.
year old,
Yeah.
the last eruption of the Yellowstone caldera.
Yeah. Let me look at the next slide for a second. Okay.
John, do you want me to sit up there and change the slides for you?
No, I need the time. Thank you. So as you come out of Ashton, you cross the river right here. Very short distance. All of this along here is Huckleberry Ridge Tuff. So if you drive along this road right here, you'll get Huckleberry Ridge Tuff. All right?
John, could I hook you up, please?
Sure.
Be better. Put that in your pocket. Good. There you go, thank you.
Okay. Is it working?
We'll find out in a second, I'll wave at you.
So, there's Huckleberry Ridge Tuff. If you look in the guidebooks, like this one, at the end, they'll talk about this. They describe this highway pretty well. They want you to look at this thing right here, but I don't advise that. It's a busy road. But so when I was trying to look at this, I saw there was a turnoff right here. And so I turned into this subdivision. And there's a reason that turnoff there. That's right between those two tuffs. That's where the development is. And if you go in there, you'll see a pumice fall. So it's not tough. It's like the ash and pumice from the, say, the first kind of volcano, like standard kind of volcano eruptions before the whole caldera collapse thing. It's not very thick, but that's where they built in here. It's much easier to bulldoze than, say, a tuff.
Did they just take the slag and from construction and throw it to the side?
Right, like I found this in the ditch by the road. In fact, the whole thing is made of this. The whole subdivision's built of this stuff. And so, and it must be stable, even though you can, throw it around, it's very low density. It's still there, the subdivision. This is a tuff, these two pieces. And which I didn't know what a tuff was for a long time, till listening to some of the speakers. But when the phrase I've heard that really worked for me is boil over. So the caldera has a boil over event. That's that kind of a mixture of gas and small crystals that's rushing out at hundreds of kilometers an hour. It's not shooting up in the air. It's because it's kind of dense. It's not like carbon dioxide gas. It has a bunch of gas in it, so it's flowing along the topography, and then as it cools, it settles and freezes into a rock. So if you look at these closely, you'll see small crystals. But it's hard to identify what's what because everything is so small. So that's a nice, easy drive right there. It's peaceful. I never ran into anyone. It's kind of a quiet subdivision. It's probably a nice place to live. So, to find information, I'm only going to show a couple sources of information, the ones that work best, so not to overwhelm you. This is the places I go when I'm trying to find something. This stands for National Geologic Map Database. It's published by the United States Geologic Service. If you went to the USGS webpage, you'll be overwhelmed with choices. But if you go to this page, so I just type this into Google, and you'll get a couple choices, and I go directly to map view. So if you go there, this is what you see. Now, if you click on the map view part, this comes up. It can take a little time if you're on a slow connection, but if you're a reasonably good connection, it'll come right up. These are all different kinds of maps that the USGS has. And you zoom in on a section. So if you zoom in by Yellowstone, it starts to look like this. Then if you left click, a box like this will come up and it'll ask, do you want to see maps or publications? And if you click on publications here, you'll get a list like this. Now, I knew I was supposed to look for somebody named Christensen, okay? Robert Christensen did a huge amount of work on Yellowstone. He's the one that established there was 3 caldera eruptions and mapped everything. And I heard this name mentioned at one of the talks, I think. So, so I searched on that, and this publication came up. This is a USGS publication, and I really recommend those because they're self-contained. It's like this is, maybe it's 80 pages, I don't know, a lot of which you don't need, but it's not like a journal article where you have to get 10 of them and you have to look up words all the time because you don't know anything. If if you start at the beginning and read this, you'll learn a lot about Yellowstone and you won't have to go to other sources. Most of the maps you see of the caldera eruptions came from this. He has really nice drawings, maps, photos. So that's what I followed when I was going up there. This book, it tries to do so much that, there's 3 pages on this area in here, on that road through Ashton to Max Inn. Okay. Any questions on that, the map view, the Geologic database? This is the most useful site of all of them that I found.
The publications, are they journal articles or USGS things?
It's almost always USGS things so far. It's
They'll lead to it, because they'll probably cite them. I assume they'll cite journal articles.
Yeah, I'll show you where to find the journal articles, but journal articles have all kinds of problems. So I try to start with these. And Wyoming publishes things too that are good. Okay. Oh, I want to go back and do one thing. So this piece, you can see the black glassy kind of material. That came from right there. Okay? Obsidian, not a very nice looking one, but it was interesting to me because this is this tough, but this part here must have cooled so fast that it made this glassy thing. So you can kind of see a big picture, which most of the tuff that you find up there looks like this. Let's see if I got it. Oh, and one more. If you go out on here, there'll be little rhyolite domes, maybe 50 feet high. They're very small. I didn't know to look for them except from the articles. And this is very light too. But you can see bigger crystals. It cooled slower. All right. Okay. Now, if you went the other way on that road from going from up to Ashton, if you went south on the highway, of course you get to Idaho Falls, right? And here's Iona and Ammon, 2 little small towns on the east side of Idaho Falls. The windmills are right here, biggest feature, and this is a raised piece of topography right here, a kind of hill. This is Blacktail Reservoir, or I've heard some people call it Ryrie Reservoir. And this is Ryrie Dugway. There's a couple things out here called Dugways, and just means they built a road, as far as I can tell. Dave Adams took us to this Dugway right here. And the reason I'm including this is because this shows the tuff layers below the ones at Ashton. So you can see the 4 to 6 million year old Heisey volcanic layers right here. And if you drive around and look at this piece, you can also see it. This is the nicest one right here. And what Dave showed us is one layer of material surging out of the caldera. Like, pretty interesting. That's where this piece came from. where gas was escaping from a rock, so it has all these bubbles. Lisa Morgan, another USGS person, has written extensively about this and does a nice job. So if you want to read about High Sea Volcano, just look her up, and I'll show you how to do that. Dave Adams, of course, knows a lot about it too. He's the one that told me about Lisa Morgan and gave me the paper to read, which is a very good paper. So when I read that Christensen USGS bulletin, he talks about Yellowstone type volcanoes in other places, Australia, Norway. And so when I was reading about it, there's actually Yellowstone type volcanoes from British Columbia down to Chile. They're all over, they're common. I thought Yellowstone was unique for a long time, and it's a little unique in how far inland it is, but it's not unique as far as a type of volcano. They're common. And
When you say type, can I ask there? When you say type, what are you talking about?
I'm talking about something that's, say, 50 to 100 kilometers across that had a caldera collapse,
Okay, as opposed to a
cone-shaped volcano that shoots some ash out. You know, I haven't found a technical word for it. That's why I keep calling it Yellowstone type. And
It's a caldera type. Yeah.
but you see the word caldera for something like that small volcanoes like the one in Oregon. It's filled Crater Lake. They'll call that a caldera. It's not really the same kind of thing. Go ahead.
But Yellowstone is a hot spot where the others are.
Well, that's kind of a cause, but I'm just talking of descriptive of the features. So, a long time ago, I read this book, Devil in the Mountain, and as I was following him around on Google Earth, he went to this Altiplano, or Puno district of Bolivia, Argentina, and Chile, where they come together. That's what this map is showing. These are the borders of Bolivia, Argentina, and Chile. And so this whole area right here where my hand is covering is filled with Yellowstone-type volcanoes. They overlap. They haven't all been mapped. And this is a famous one. Like if you looked up Altiplano in Wikipedia, they show this picture. This is a flow that's several miles across. It's pretty interesting, and it hasn't been eroded very much because of the, it's a desert, driest desert in the world. When I first saw this, I thought, oh, I have to go there. But when I looked at photos, it's a pretty bleak place. So I don't know. Diane wasn't interested. She wanted to go to southern Chile. But I guess the big lesson I want to get across that was new to me was there are Yellowstone-type volcanoes all over. Every subduct, like Sumatra, the Caucasus Mountains, any place where things are happening tectonically, there's probably a Yellowstone-type volcano. What really brought this home to me was we had a speaker from University of Michigan that was working at the field camp, and he came up, he was working in the Caucasus Mountains, and he talked about one. And when I asked him why it was there, he looked at me like I didn't know anything. You know, they're everywhere. So, all right, next place, drive to Copper Mountain. No connection to Ashton. It's just another example of how to find information, and a place I've been going to the last year or two. All right. So here's Jackson. You go north to Moran, over Togedy Pass. Go to Riverton, head north to Shoshone. You could, and this is the road through the Wind River Canyon. Here's to Casper. So you go north on this road just a few miles. Here's the Google Earth view. So here's Boysen Reservoir. So it took me a while to figure out how to just drive there.
Before the canyon?
Yeah, it's before the canyon. I'm going to show some details. This is also called a pegmatite, and we had somebody talk about that, and I'll show you his name. This is another pegmatite I've never been to. It just came up when I was searching. You know, a lot of this area, I don't know how well it's been explored. I mean, I assume somebody's walked across every square mile, but that doesn't mean we know about it. You know, it's a pretty empty area. Lots of oil wells and gas wells. Okay, so as you drive north, going along Boysen Reservoir, this is hard for you to see, I know, but this is Google Maps, the kind of thing that would come up on your phone. So, if you take this first road, make sure I'm doing this right, and come up, you'll get to a ranch right here. All right? This is bad water here. If you go up a little further, and I'll show you how you could find this exactly if you want, but if you go up a little further, then you get to Tough Creek Road, which goes up this way and accesses the core of this district. It's a terrible road, though. Like for a big pickup, four-wheel drive, or a Jeep, something like that.
So is it BLM or forest, or what is it?
I think it's BLM. It's public land. There's signs on it. Because you cross private land in a couple places. It's very tricky, the access, which I'll get to.
But it's not on the reservation.
No. No, there's a bunch of private ranches in here. That's what complicates the access. If you go up a little further and take this road, then you can take a back road over the top of the Owl Creek Mountains to Thermopolis if you want. But you can also come in to the top of this feature. Let me do one more slide first. So here's Google Earth looking at those same roads. So if you take the Badwater Road and come up here, you'll get to a ranch. Here's the Copper Mountain feature in here. And you can't get any access through this road unless you just park by the side of the road and start walking, and which we did, and we walked up on top of one of these mountains, too strong a word for it. It's just a hill, I guess. And on top of these hills, you'll find bull quartz. That's what Chuck told me to call it. They'll be about this big around, quartz coming out of the ground, surrounded by black metamorphic rock. Basalt, metabasalt, it was probably ocean floor. It's been metamorphosed. And then it's had igneous intrusions, which put the quartz in. If you go up this road right here, then you get a vertically dipping ridge of banded iron, which is this stuff. And you'll run into a ranch again. But before you get to the ranch, this is public and you can walk around. This is actually right next to the road.
Are you pushback, or are you just walking up the road?
Just walking up the road. This one we went off the road maybe 100 yards. But it made a nice place to put the road with this dip. Like if you go just to the south of it, then you run into the Cambrian flathead sandstone and all those features. So you can take this road and come up, and you'll see the granite intrusion up here. Metamorphic rocks are all down through here. It's a fairly big area. I haven't been to all of it, or even a small part of it. This is the road you have to take if you want to drive around inside it. Like if you go drive up here, you have to walk down into it. So you take the Tough Creek Road. There's an oil facility, or maybe it's natural gas, I don't know which, right here. That's where the main road goes to. There's a little obscure two-track right here. That goes up a little ways, and you'll get to a fence where it says it's public land, but please close the gate. Once you get past that fence, it's going through a dry stream bed where you go up and down like this at about 1 mile an hour for about 2 miles. Then you're in it. And once you're in it, it's fairly flat area with good roads. It's covered with roads because there was mining. When they did the mining, I don't know for a fact, but I assume they bought an easement through here because there's a huge road right here and it goes to some of the mining sites. And so, like they did beryllium mining in the 80s and in this area. But he doesn't let sightseers in. So you have to come up through here and then you have access to it. I didn't put any photos. I don't have any, but the reason I didn't take any is it's sagebrush covered hills with some juniper. It's hot in the summer. I wouldn't recommend going there in August. April would be a good time.
Would the streams be active then?
I've never seen water up there. Well, there's some springs up here, but I've never seen water in that dry stream bed. I went in the spring once. It's got to be water there sometime because you'll see some of this black metamorphic basalt down here. There'll be like lines of it along the road. So it got there somehow.
John, have you ever gone to the rock shop in Thermopolis?
Yeah, I'm going to mention them. I got a photo of it. I've gotten a lot of help from 3 rock shops because I don't know that much about mineralogy, and so I would buy samples so I know what to look for because they'll label them. So I went to MapView, trying to find a map, because the first publication I read about this was by Dan Hosel, who worked for the Wyoming State Geologic Survey. And he didn't have a nice map, he just had a crude map. So as I'm zooming into Copper Mountain, this is what I see. So this is a good illustration of something that can happen to you. This is a wide map here. This just shows landslides. I don't even know why they paid somebody to map all that. But then if you zoom in further, then all of a sudden it changes and you see this. Just by zooming in, you get a high resolution map on a smaller scale, and this is a surface geology map. This stuff here is granite, this is metamorphic, and this is Cambrian sediments. If you do, I think it's browse, I can't read that, but if you do browse, then you get this page come up. This is how to get a map. And there'll be a map like here that you can click on and actually look on the internet if you wish to do that. It's kind of slow. If you go over here, you can download maps. And I recommend these TIFFs. The biggest reason to get the TIFF is so you can read all the writing, because there's lots of useful writing on the maps. And then download it. It doesn't cost anything. Then what you can do, if you're going to go on a hike or a trip, is you can email that map from your computer and email it to yourself, and then check your email with your phone and download the map that way. That's the easiest way I found to put it on a phone. I tried using Apple's software, which was terrible. This thing for music, what do they call it? iTunes? That's what you're supposed to use to move files back and forth, but it's worthless.
So John, just a few weeks ago, I was looking for geologic maps, and I actually called the Wyoming State Geologic Survey and asked if there was a Google Earth image with navigation, with a geologic map as the backdrop.
Yeah.
And there's not. So, but that would be ideal, right? So you
Yeah,
can actually
yeah.
have the map and show where you are on the geologic
Yeah.
map.
So there are programs that will allow you to overlay that.
There are.
On top of it.
I looked at one overlay, but it's so low resolution. You know, and if you're out walking around, you want the highest resolution thing you can get, which these little, I think they're 15-minute maps. They're really good. You can look, because one thing I use these maps for is to learn to identify rocks, because on the map there'll be a legend over here, and it'll say, in this area, this is the rocks you're going to find. So it's kind of like trying to identify a plant. It's a lot easier if you have somebody that tells you what plants are in this area. You know, instead of going through the list of things in Brazil, let's say. So it will tell you a few minerals in this area, and that's a lot of clues. You know, if you know nothing, any piece of information is useful. And then you can click on publications. And the publications, let's see if I got Hausel's. Yeah, Dan Hausel. He worked for the Wyoming State Geologic Survey for many years and wrote a lot of great reports. He's very oriented towards economic things, so he's mad that Wyoming doesn't mine for gold everywhere. So he doesn't work for them anymore, but he did write good stuff. He just has this attitude, I guess. I'm sure the state geologist was glad to see him go. He writes on the web, it's bad things.
Someone just told me about this map, or this app. It's Rock, R-O-C-K-D, and I just downloaded it yesterday. And so it may be more generalized than what you're wanting the detail of, but if you want to be oriented, it does that, and it gives you chug water formation and this and that, without quite the detail, well,
Yeah.
I think much of the detail, but gives you all kinds of references. And we had the USGS, the Wyoming version, when they finished a big map, come up here and lecture, and I bought it, and I was looking for it online, on my phone, and it's gone. So I don't know.
The state map you can get, and I recommend getting the state map.
And I had it, and it had so many layers. You could find railway tracks, all kinds of things. So I don't know where it went, but yeah, it was like.
I couldn't get it through the map view. I had to go to the Wyoming State Geology Survey, and I think maybe they sent me to the college, you know, on the internet.
It's a very complex, very thorough map.
Those state maps, each state's kind of picky. Like Idaho, they want you to pay for it. They don't give it to you for free. Most of the maps, like Montana, I couldn't get it for free either. But most of these 15-minute maps are free, and they're the best. They're easily the best.
And you find the PDF, the TIFFs are more higher resolution than the PDFs?
Yes, I prefer the TIFFs. The other thing I like about the TIFFs is every computer and phone can handle a TIFF format. The reason I got picky about it was the writing, because on some of those maps there's very dense writing, big columns of it, and so the writing is just as useful as the map, and so.
And there's actually 7.5-minute maps
Yeah.
locally, which have twice the resolution
Yeah.
of the 15, and there's quite a few published for the Tetons.
Yeah, I found one for the Targhee when I was up there. Okay, to find some documents about this. In fact, I knew which document I want because he came to speak. It was, of course I forgot his name right now. Jacobson, Mark Jacobson, friend of John Herberger's from Chevron. He came to speak to us about the pegmatite, and he wrote a paper, and so I wanted to get that paper. You know, because he obviously knew a lot about it. So, the first thing I tried was Google Scholar. Google Scholar searches through journals, all right? It's not newspaper articles, it's not fluff, I guess. The big problem with searching Google Scholar is you can't search by image. Searching by image really helps in Google. But in any case, it's still useful. I couldn't get anything though. I even knew exactly what I was looking for, so it came up. I just couldn't get it. Sometimes on a journal article, if you'll see that it's located at the university, because the universities are fighting back against the journal publishers and making their scientists publish at the university. There's a big war going on between the publishers and the scientists right now about access to articles. And like the American Chemical Society is suing people, has $15 million judgment against somebody. But anyway, geology is much easier to get papers. So I searched Mark Jacobson, got it up, but I couldn't find it. I went back to Google and I got a bunch more stuff on the regular Google. And it came up in this ResearchGate thing. Sometimes works. You know, these journal, all this stuff was paid for by us, by our tax dollars. We're the publishers, really. The scientists don't get paid for writing them, but there's these intermediaries that have locked it down pretty tight in some cases, except for physics and math. In physics, they just took it over. Okay, so there's 2 great papers on Copper Mountain. Economic Geology of Copper Mountain by Dan Hausel. He wrote about South Pass, that's how I knew about him. He's written about a bunch of interesting areas in Wyoming. And then here's Mark Jacobson's paper. And I recommend that if you go to Copper Mountain. He'll give precise driving instructions, tell you what the minerals are up there, and some of the geology history. Dan Hausel's paper is good too. He writes about it more as a professional geologist, where Mark Jacobson is writing for like rock hounds, mineral collectors, people. This photo right here is this like mica and granite, comes from this site right there, which you can walk up to pretty easily. So he gives precise driving instructions from the highway to get to the site. Tells you all the ins and outs of why you can't go to this way because it's restricted and what you'll find. I have copies of all these things too, so if you don't feel like searching for it, I can give you one. This is something I just found this weekend when I was going over this. It's published by the Wyoming Geologic Survey. It's iron resources. I don't know why they care about iron resources in Wyoming. You know, we had an iron mine and they closed it because it's kind of a strange place to mine iron. It's so far from anybody. It's a very, you know, freight's a big issue on things like iron. You can't imagine moving iron to the coast or something. So it was quite reasonably shut down. But this paper shows all the iron places in Wyoming. And the nice thing about that is wherever there's iron, or most of the places, are very old rocks and the interesting rocks. Metamorphic rocks, all these kind of interesting minerals. They're usually 2-3 billion years old. So this is like a list of the interesting places for me to go visit. Like reading this, the Arlington exit on Interstate 80 goes right to a camp, you know, not a picnic ground, right off the interstate, which is in the middle of one of these old features. So I'll have to go look at that the next time I...
Arlington, Wyoming?
Yeah, it's an exit on the Interstate 80 as you're going from, say, Rock Springs to Cheyenne. And you can get a map. It'll tell you all the... So what they're trying to say when they were talking about Copper Mountain is there's 3 metamorphic regions, then the igneous. Here's the banded iron, this rock. I'll go over all these rocks later. And there's garnet in here. So the metamorphic grade right here is higher. And by metamorphic grade, I mean the pressures and temperatures were higher than, say, South Pass. And so it's changed these rocks more than, say, in South Pass. And what Dan Hausel said when he looked at it, for some reason, these people know that high metamorphic grade means there's no good minerals, like gold. Gold's the best thing. And I don't know why that is. I mean, if it had the same amount of gold to start with as South Pass, why does a higher metamorphic grade change that? But that's what he said, and it must be true. There's no gold mines. There are lots of mines for things like beryllium, what else were there? Tungsten. All closed down now. Okay. You know, I was educated as a chemist, so I'm going to try to use chemistry to explain a mineral to myself and maybe to you.
Okay. It's very intimidating to get a book on mineralogy and they'll tell you, you know, oh, look for this crystal structure or that. And, you know, you have these rocks that look like this. You know, nothing in this rock looks like in the mineral book. You know, they always have these perfect specimens. And they'll tell you to do a scratch test or something. You know, how do you do that? What's worked for me is to think about what's likely to be out there, like reading the map, but just thinking about it in terms of geology and doing a couple simple tests and just getting familiar with some of these things. So if you start with an atom, spherically symmetric, like silicon, then you make a negative ion, which is going to be a platonic solid, and I'll show you some more of those in a bit. There's only 5 versions of that. So this is like the silicon with 4 oxygens around it, has a negative charge. Like last winter I showed you iron, it made a octahedron solid, but was surrounded by oxygen. Then you take these platonic solids, which this one's a tetrahedron, you combine it with the positive ions to make a crystal.
What does the word platonic mean in this context?
Plato was a Greek mathematician.
Right.
He classified them.
So it's just referring to the type of...
Yeah, I'll show it. The next slide I'll show you. If you go to the mineralogy book, they just show a bunch of these different things and tell you to look for that, which, I mean, doesn't work for me. I have a hard time telling the difference between quartz and, say, limestone crystals without testing it. And, you know, it can be difficult. Okay, before we get to the platonic solids, we're going to do something simpler. Look at a polygon inscribed in a circle. All right? Triangle, square, pentagon, hexagon. And you can keep going. There's no limit on how many of these you can do. Only the triangle, the square, and the hexagon tile a flat surface, meaning you can repeat them and it will cover the entire surface. That's important when you're looking at, say, those basalt cooling structures. They're all hexagonal columns.
That's changing with the quasicrystals that have been found.
Sure, that's a unique exception.
Yeah.
It's not, the quasi-crystals are really not a repetition of this thing.
They're not regularly repeating sets of atoms in
Right.
three-dimensional space.
Right. They're interesting. He got a prize for it, and I don't understand it that well, so I can't get into it in detail. When you go to 3 dimensions, then there's a lot more restriction. There's only 5 things that will fill a sphere, 3 dimensions. Tetrahedron, cube, octahedron, dodecahedron, and icosahedron. There's a crystal example of all of these. So to build a crystal, you're going to take these things and try to fill space. These will be, here, let me go back to, this is the only one that will fill space. Like sodium chloride, you can stack those cubes up and fill space. All right, so it's a pretty simple structure. So that's the one they show you in freshman chemistry. Iron oxides are going to be in this, silicates are in this, and you can't fill space with it. You can't just stack them together and make a big building out of that. There'll be gaps. So silicates always in a tetrahedron, and I'm going to show you how to put some of them together. A couple examples. Here's the kind of things you might see in a chemistry book or a geology book. It's a negative ion. One of the things these don't show that's very important for understanding reactions is they're static and rigid looking. Like that looks like bars that you can't break. Right? So I'm going to show you an example, an experiment to illustrate a different aspect of the chemistry. So this is a water droplet suspended on in an acoustic wave. So the water droplet's going to be like a molecule. The acoustic wave is like a light wave. it'll interact in the same way a molecule with a light wave would. There'll be quantum transitions, it has an uncertainty principle, vibration, all that. So let's see if I can. It only takes a minute to run this video. So this is what, how do I turn the volume down here? Mike, how do I turn the volume down?
There must be usually there's a volume control.
Oh, I just meant on your computer.
Oh, I never do.
All right, we'll just leave it for now. So this is like the electron in the molecule. Okay, just went through a quantum transition. Another one. Okay, now it's ionizing if you want. All waves have an uncertainty principle, okay, not just electrons. And there's some music theory books use it now too. And the quantum part is because there's a boundary condition that a wave going around a circle has to match coming back. And only certain wavelengths will match. And that works in a water droplet or a molecule, doesn't matter. All right? And so it's only going to absorb certain acoustic frequencies, ones that will go from 2 wavelengths around to 3. So there's nothing magic in an uncertainty principle or a quantum transition. It's just from a boundary condition. The uncertainty principle I'm not going to get into because it's unnecessary for what we're doing. I'm saying it because there's so much garbage out about it being like a mystical thing or something. These are 2 other good examples of these kind of experiments. So when you look at these rigid frames, I want you to keep in mind that it's actually a very dynamic thing, and as you increase the temperature, it can change, fall apart, react. All right, so all those tetrahedrons that I've been talking about, they go in these arrangements. There's a 3-dimensional quartz and feldspar that I didn't draw in there, but that's it. Maybe there's a few exceptions, but everything I see is made like this. So there's, where's my olivine? My olivine.
Right here.
Yeah, thank you. I can't see close with glasses. Generally, there's some general trends. Higher density, lower density. That's not perfect, but so this would be under pressure, deep in the earth, more at the surface of the earth. So here's olivine. It's green, little green crystals. It's isolated tetrahedron is what it would be called. It's not forming a polymer. So each tetrahedron is surrounded by some positive ions. And the reason it's classified like this, if you were to look up some of these minerals, they're not very definite about which positive ions. It's like a soup sometimes. Sometimes they'll be precise, but sometimes they'll say there's some calcium, there's some sodium. You know, it's not classified that way. It's classified by these silicate arrangements of the tetrahedrons. So olivine, The garnets, which I have one here, these are the only mineral I've seen that are in that dodecahedron type shape, or the negative ion is. And then here's a piece from Copper Mountain laying by the road that's full of garnets because it had been put under the old seafloor had been put under enough pressure that it metamorphosed into garnets. Here's a piece of pyroxene, which I've never seen a big crystal of pyroxene in Wyoming. And Chuck Dahl said there are always little short stubby things in the rocks, and they're not very common. They're almost all amphiboles. The pyroxene's kind of unstable. It would, if you, as far as I can tell, if you were to give enough heat, this would quickly turn to the amphibole. And one of the theories about those kimberlite pipes, and there's some of those in Wyoming, is that you get a very fast reaction between this deep in the crust, like 100 kilometers down, that this turns into that and releases so much energy it shoots up a pipe of material. And along the southern border of Wyoming, there's a few of those. So pyroxene. So I had to get this one from Canada. I'm trying to get one of each of these. That's my collection. And a nice thing about collecting these, they're common, and so they don't cost anything. Okay, this. Here's a crystal of tourmaline from from Copper Mountain. And you can see it's in the mica feldspar rock. It's an igneous rock, the tourmaline, or igneous mineral. So that's this. If you look at it, these things are stacked out. So it makes kind of a column shape. Here's some epidote crystals. I don't understand how that goes to this crystal, but I just got this from the rock shop. Most of the epidote that I see in Wyoming, and there is a lot of it, it'll be a pistachio green layer in the granite, probably from metamorphosis of the granite. Okay, there's a bunch of amphiboles. You probably should look at these closer, but
you can look at the actual crystal in the rock and identify with these kind of structures.
I can't, no. Except mica. This one I can. Well, I shouldn't say that. The tourmaline, after you look at it for a while, you can see tourmaline up in Copper Mountain. You know what to look for. And like if you come up and look at these amphiboles, you'll get the idea. Like if you look at this one, you'll see lots of lines. And so from looking at this, I thought, well, it must be pyroxene or amphibole, because I also read the geology map. It said they were there. So I took it to Chuck Dahl and asked him which one it was. And he said immediately it was this, because pyroxene never makes crystals that are long like that, at least in Wyoming. And you can see this pattern. And this, if you look at this thing, but like most of the rocks, like if you looked at a sandstone, it's a bunch of tiny crystals. You can't see the shape of the crystal, or I can't anyway. But this works better for me anyway than the mineralogy book, which classifies them by these three-dimensional crystal shapes. Okay. On the mica, some of that mica is from Copper Mountain, but I brought this one piece from Utah because besides being a sheet, it also has a hexagonal shape, which you can see in this piece. Some of these micas are hexagons. This mica from Copper Mountain is a little different. This is a lithium ore, lepidolite, I think is what they call it. But it's a sheet. So Copper Mountain was somewhat interesting to me chemically because there's a lithium ore, tourmaline is a boron ore. And I'll show a picture. The beryl is beryllium. This one was mined in a couple places. I don't know the geologic significance of that, but they're up there in enough quantities. They were mined at one time. Here's some amphiboles from Wyoming, and there it is. I have a piece of Wyoming jade. It's an amphibole. And hornblende that you see in a lot of the white and black rocks. A lot of the black is hornblende. It's an amphibole. So when I think of these mineral names now, which there's probably 500 common minerals, many in this area, I always go back to this classification first to think about what it is. And then, if it's an amphibole, then there's a few different kinds and maybe it means something, maybe to somebody else and not to me. But so that's at least how I'm thinking about it right now, which is helping. Here's an X-ray diffraction of the amphibole. This isn't a drawing. This is what it came out, and I'll show you where to get that. So this was my favorite X-ray diffraction one. This is beryl with the thing they're mining up there. Like, here's a photo of a nice crystal from Casper Mountain. Casper Mountain has a lot of this metamorphic rock too. You can see the hexagonal shape. So the beryl is the green. So beryllium is atomic number 4, and it's used something to do with X-ray. Like, there's little beryllium windows in X-ray tubes. I don't understand the purpose of it, but there's probably lots of other uses. But so I was reading a journal, and they were making drawings or making images like this, and they used this program, which is free and easy to operate. It took about 10 minutes to download a structure from this American Mineralogists database. You download a structure and you can put it in there and rotate it around and see what's going on. So here you see these hexagons are kind of rotated but stacked up. And you can see this mineral has lots of holes. So people who are trying to sell these things to a purchaser, they'll have problems if the mineral has holes in it like this, because lots of other things will be in there. Like quartz is like that, which I'll show in the next photo. So other things besides the beryl are in here, and if it's important about purity, you'll care what's in those holes. So then they'll go around and find the best beryl. Yes?
Beryllium is transparent to X-rays, which is why it's valuable.
I guess I should say one thing I like about this that has nothing to do with science, but as you're walking around in the world, it's kind of chaotic, and except in buildings and things, there's no straight lines. It's messy, curved, chaotic. But if you go another level down, it's very regular, which is kind of counterintuitive to at least how I was brought up. Like, I'm sure some of you have heard that phrase, there's no straight lines in nature. But if you go down a certain level, that's all there is.
Now, that structure relates to that topmost category that you showed on your diagram, right?
Yeah, let's go back to that.
Let's go back and let's see how that relates.
So, beryl.
So it's a single one of these.
Right, and they're stacked.
Okay, so the difference between the amphibole and the tourmaline structure, I mean, the amphibole has...
The difference is these are bonds here. There's no other silicates bonded to this hexagon. There'll be positive ions in there. But, that's a good point. What you're getting at is that these things are very similar. So you can see if you put two pyroxenes together that it could react to make an amphibole fairly quickly, right? Because it doesn't take much rearrangement. Little rotation, if they're in proximity, and it just depends which is more stable. So here's quartz. These are, again, X-ray diffraction results. So this is the kind of quartz we normally see, which I have an example of. This is high temperature quartz, and by high temperature I think they mean 500 Celsius. It forms a different arrangement, which you can see. So I only have a small one. I've only ever seen small ones. So here's the high temperature. It's more symmetrical. And even the X-ray pattern's more symmetrical. And where this high temperature quartz came from is the Judith Mountains in Montana.
Meaning it's high temperature because it was formed under very high temperature.
Yeah, at room temperature this is unstable. I mean, maybe it takes 1 million years to convert to that, but if it's cooling slow enough and it goes below, say it goes to 200, then it'll all be this form. And you can see in the quartz structure there's holes, all right? And the holes will be filled with like this clear quartz right here is probably only 99% quartz, maybe less than that. It's 1% other stuff. So people who make silicon for like products, they're going to add things to it, and they don't want other stuff that they didn't add in there. And so they look around for quartz that's the holes aren't filled with stuff, they're pure. And there's an example of that in North Carolina somewhere. It's special quartz, it's extra clean. And so
Well,
even
the semiconductor industry uses quartz for lots of things. I mean, in terms of glassware and in the processing. So
Yeah.
I'm sure that they want it extremely
yeah, I guess
low
it's
impurity.
it's a very big craft to do this silicon thing. I read about a little after I was doing this, and it's a complicated process with lots of skilled people. They have to make, like to melt the silicon, they have to make a quartz vessel, and they don't want that vessel to contaminate so it's not something you do in your, at least I couldn't do it in my garage. But I read about somebody 30 years, or I guess it's getting 60 years ago, doing that in a garage. Shockley, is that the right guy? So it must have been a fancy garage, but
Bell Labs
yeah, yeah.
after the war.
So that's my approach to doing these minerals.
So, like the brown quartz there, the holes in there are occupied by iron or other ions, and that's what's coloring it. Because normal pure quartz is going to be transparent, clear.
Yeah, I think that's true. I don't know for sure, because I haven't really researched that much. Like the other way you could get impurities.
Because quartz can be any color. I mean, amethyst is quartz.
I mean, I got off on the whole thing. That's where my reading took me. But you could have impurities for other reasons, like the silica inside a tetrahedron. Maybe the silicon atom's removed and an aluminum's put in there, or a iron +2. All right. I don't know that that's common in quartz, but that does happen in other metals. Like to make a feldspar, you take the silicon out and put aluminum in, and then and it's got a different charge, +3 instead of +4. So you have to add something like sodium. So you can get replacements inside these things. It's not absolute. As far as another thing that can happen too is, which I've read about, some of these minerals that people sell in the gift stores are manufactured in a factory. And one of the things they do is they'll irradiate with radiation, which will disrupt the structure so that the way light goes through it changes, and that will change the color. And so I saw pictures of big racks of minerals being irradiated to make them the right color to sell. And there's other heat treatments and
Right, they actually take black quartz, clear quartz, like from Arkansas, and they bring it to an irradiation facility where they're irradiating medical equipment and everything else.
Yeah.
They just put it on the belt and they run it
Yeah.
through a couple of times and it turns black.
that never occurred to me that anybody would go through all that effort, but it's actually a fairly big deal to make these colored gems. And in fact, if you just went to Wikipedia to read about minerals, it can get very confusing because you'll get led astray by the gem industry. And then you'll be reading about healing crystals and things too. Okay. So these are the 3 rock shops that I've been to. They were all helpful. Okay, so I'll start at Driggs. This is Driggs Plumbing. And the guy who started this is named Driggs several generations ago. I don't know whether that's related to the name of the town or not. But anyway, it's on the 3rd generation, and they're making some changes now. So now I see the last time there was a sign saying candy for sale. So the guy that had it before, the father, he had big piles of rocks everywhere. And kids maybe don't like all those piles of rocks, but they're still selling the trinket kind of things. And there probably is some good rocks in there. But so that's right on Main Street in Driggs. Okay, this is Rock Solid is in Riverton. Alice is the person I met there. She has a mining claim on Copper Mountain. And she absolutely refuses to lead field trips or tell me anything, except this one's $30, this one's $10, you know.
Can't you find her mining claim?
Yeah, I could. And she was helping me, so I wasn't, yeah. She helped me identify things. So that's how I learned what tourmaline was. You know, she was showing it to me, and some of the other minerals. She's helpful. She's just not interested in turning you into a competitor. I don't really know anything about her history. I think I kind of put her off when I asked her if she would lead a field trip. She kind of looked at me like, ah. And then this is the rock shop in Thermopolis, Ava's Silver and Rock Shop. Eddie and Ava are field geologists. They worked in setting up the dinosaur center, and they don't like the guy who owns the dinosaur center. That's what I got from them. They don't work there anymore. They helped set it up and then probably were laid off. But they're friendly. These are all giant samples of some of these things, like a 1,000-pound piece of the amphibole or the lithium mica, giant pieces sitting out there. They're also kind of cagey about where things come from too, because they have a handout about how to find some of these Copper Mountain minerals, but their handout doesn't take you to Copper Mountain. It takes you to a couple of other places on the way, and they don't give instructions. But they're all nice people. We're helpful, and so that's why I put them up there. So besides the geology maps, which will say, in this spot, you're going to find metabasalt. The other place to learn about minerals is to go to one of these places and ask them questions. And, you know, a little familiarity with what's around helps a lot, I think. So I don't have the mineralogy book when I'm walking around in the mountains. I'm trying to figure this out. You know, I have that map on my phone sometimes, and then I come back and, like, Chuck Dahl's a good resource. I ask him if I'm confused, because he usually knows it instantly. Not always. I've stumped him once, but I brought him a rock from the Judith Mountains, and he knew where it came from without me telling him. He knew what kind of mountain it was and everything just from the mineral. So he's very good. He's not getting out that much anymore. Okay, that's it.
Hey.